Back. Let's take a journey back to where we started and where we're going. We started with this. I gave you a circle. Right? I gave you a circle that said the arc measures 90 degrees. And I wanted you to find the arc length. So when we started this process, I was asking you guys to find the length of that line. That was what your quiz looked like. And for that to happen, you had to do arc length over circumference equals arc measure over 360. So the circumference we were writing as 2 pi r. So we were solving for the arc length by doing the length of the line over the circumference equals the arc measure over 360. Now today, I'm going to ask you guys not to find the length of the line, but to find the area of the wedge. Find the area of the wedge. So it's kind of the same process. Today we're going to look at the sector, which is the shaded region, over the area of the circle equals degrees over degrees. So I'm only changing the left-hand side of the formula. It's the area of the sector over the area of the circle equals the number of degrees you have over the total number of degrees that there are. So if we're going to write this down as a formula, let's just practice first with, can you find the area of a circle? What is the area of a circle? All right, and it says the formula is pi r squared. So
we need the radius.
the area of a circle is equal to pi times the radius squared. Now because the diameter is 6, the radius is 3. And everyone today has goofed this at least once. You have to compute 3 squared. 9, not 6. 3 times 3 is 9. So the area of this circle is 9 pi. Now if you don't like the pi answer, that's okay. You can convert that to a decimal by typing in 9 pi. 28.27. Either answer works. Nine pi and 28.27 are the exact same answer. Sometimes you're going to have to.
Yeah, because on the test you want to.
So on the test, a lot of the answers are in terms of pi. Okay. So today we're looking at, can we find the area of this piece of the pie? So we want to use area of the sector over area of the circle. That looks like this. Pi slice over the whole circle. Right? Area of sector over area of circle. And it should be equal to the arc measure in degrees over 360 every time, all the time. So this is the formula that we're going to use right here. I already printed this on the back of your test. That's what's printed on your test. It says that circumference equals 2 pi r, and arc length over circumference equals arc measure over 360. The area of a sector over area of a circle equals arc length over, it's on the back of your test, printed there. So now it's just how good we are at using it. So let's use the circle over there. What is the area of the red sector that we're trying to find? How?
That's 60 degrees. Is that what you meant?
So remember, our formula has area on the right and degrees on the left.
I thought you were on the left. Or the right.
We're on the left side. What is the area of that wedge? We don't know. We're going to call it x. And how do we find the area of a circle?
C
Close.
A equals. Oh yeah, A equals I R.
Area equals pi times radius squared.
4 pi.
Equals, what is the degree measure of the arc?
60.
Over
360.
360. Now, I think I found a better way to do this. So roll with me for a second. I'm going to simplify. So when I simplify, I'm going to simplify everything. Can I simplify x?
No.
Can I simplify pi times 2 squared?
Yeah.
2 squared is
4 pi.
4 pi, right? 4 pi. And someone was like, I can simplify the right side as well. Go to your calculator and do 60 over 360. That's 1 over 6. Look how pretty that is. X over 4 pi equals 1 over 6.
So you just put like the zeros and just 60.
I can do that in my mind. I just like to show you guys the process. Alright? So now when we cross multiply to solve for x, what's 1 times 4 pi? 4 pi. X times 6? 6x. So how do you get rid of the number next to the variable? Divide by 6. Now, this might be easier to simplify in your mind. Can you reduce the fraction 4 over 6? To what?
2 over 3.
To pi over 3. The answer for the area of that sector is 2 pi over 3. So if you don't like fractions, you could convert it to a decimal. I want to show you this step because all the answers on your test are in decimals. Okay? So if I go back to this one right here, that's 1 times 4 pi, and then we did 4 pi divided by 6, right? So you can type that in your calculator. 4 pi divided by 6, 2.09. So you know that the decimal equivalent is 2.09 or like 2.1. Now, how does that decimal help you to cheat on your test? You can go through all your answer choices. 1 pi over 6 and enter it. If that's 2, then that's the right answer. 2 pi over 4, put enter if that's the right answer. So if you had an answer choice B that was 2 pi over 4, is that the same as 2? So you know that's the wrong answer. You can convert it to decimals, and you can go through and convert all your answers to decimals and see which one matches up. A lot. I mean, it is what it is. You can do anything at this point. All right, let's try another one.
But you said on the test it's going to be all in decimals.
They're all pies. They're all in pies. So you have to be able to know the pi. And this is where I'm trying to get you guys to. What is the area of the circle in pi? And what is the area of the circle as a decimal? So it says the circle has a radius of 5. But what's the area of the circle? Pi r squared. Huh? 25 pi. Or pi r squared. 78.5. It does not matter how you understand the answer, as long as you know those are both the same exact thing. When do you guys go to bilingual in terms of pi and regular answers? Is it making more sense? Kind of. Alright, this one's a monster. Sorry. So what you're missing on the YouTube is all the glorious faces reading this problem. It says, find the area of a sector RST in circle S with a diameter of 12 and the measurement of minor arc RT of 45 degrees.
See, when you read it out, it looked way easier than
Because I know how to add all the hidden words that are not there. Right?
When I looked at it, it said sector RST.
Okay, so the first thing to look at is this right here. What's the name of the circle?
S.
S. Do I have circle S?
Yes.
Now I'm trying to find, well, what's the diameter of circle S?
12.
So if the diameter is 12, how big is the radius?
6.
That's good to know. Now I need to find sector RST. Well, I can call this point R,
You call the other one
S.
T.
How big is the arc measure of that sector?
45.
So now I have all the working parts. I have a circle S, I have a sector RST, I have a diameter of 12, I have a radius of 6, and I have an arc measure of 45. Well, now I have to find the area of that sector.
Okay. Set it up.
So what is the area of the sector? X, okay. What is the area of the circle? Pi, pi r squared. How many degrees is the arc?
45 over 360. And it would be x over 36.
Simplify.
X over 36 pi over
Consult your calculator.
1/8.
45 over 360 is 1/8. That makes, who wants to do 45 times 36? Not me, but I'll do 1 times 36 all day long.
36 pi is equal to 8. 8x. Divide by 8.
So if you don't know what 36 over 8 simplifies down to, you can type it in your calculator. Control divide, 36 on top, 8 on the bottom, 9 over 2. 9 pi over 2. It was 36 pi's over 8, now it's 9 pi's over 2. Simplify the fraction. Or you can convert it to a decimal. And you get 14.1. Either way works.
That wasn't that bad.
It's not. It's just understanding the formula and how to use it. I think doing this step makes it easier. Yeah? Alright, ready? Yeah? Here we go. Now we want to find the area of the shaded region. Look at it. It changed, didn't it?
Yeah. That looks so weird.
We were finding the area
Yes, sir.
of the whole wedge.
So
weren't
now
we?
you just have to find half of it.
No, not half. We have to find. Now we have to find the area of the sector and subtract the area of the triangle. No.
I'm collision.
So let's do the first step. What is the area of the sector?
X.
X is the area of the sector. What is the area of the whole circle? How many degrees is the sector?
120 over 360.
Simplify.
1 pi.
1/3. Okay? Now we cross multiply.
81 pi is equal to 3x. Divide by 3.
What's 27 pi as a decimal? More like 85? 84.8?
It's 84.8 acres.
Is it really?
Yeah.
84.8.
Either one works. 84.8. Guess what? Step 1. Now we have to find the area of the triangle. I'm going to give you guys a super cheater shortcut. I skipped all the way to chapter 13 for this formula. And you just get to use it. You ready? Alright, so in chapter 13 it says that the area of this triangle is equal to the length from the center of the circle outside, which is how big? Times the length from the center of the circle to the outside, which is times sine of the angle. And it says it right here. The area of that triangle is equal to 1/2 times the radius times the sine of the angle. That's called the included angle area theorem. So it's 1/2 times 9 times 9 times sine of the angle 120.
This is going to be on our test?
It's not. This is where your test stops. The area of the sector is 27, right? 27 pi. So right now we know that the area of the sector is 27 pi. We need to subtract from it the area of the triangle. 1/2 times 9 times 9 sine of the angle. Yeah, it doesn't matter. 35. 35 is the area of the triangle. So if I do 27 pi minus 35, the area of that shaded region is 49.8. So right now we're just practicing finding the area of the sector first and then subtracting a triangle second. The reason I'm exposing you to this now is when we're about to do stuff when it's like hexagons inscribed in triangles, hexagons inscribed in circles, and circles inscribed in hexagons. It really, really shortcuts all the work. Alright, let's try this one. We'll do 2 more and we're done. 2 more. Yeah, in the last class I proved why that formula worked. You want to see the proof?
Yeah.
You do? 120 degrees, right? That's all we have. We know this is 9. So the area for a triangle is 1/2 base times height.
I have a question.
Yes, sir.
Can't your other side be also 9?
It is 9 because this is the center of the circle. But do I have a base or a height? So I can draw a height, right? And this H, that's how it works. I'm doing it. Hold on. I drew the line the wrong way. Look like that. That's the height of the triangle. This is the base, right? See the base? See it? This is the base. And I'm looking for the height. So the sine of 120 is equal to x. I'm sorry, or 9 over x. Opposite over hypotenuse. What happens when there's a number on the bottom? It moves to the front. So instead of writing the height, it becomes 1/2 times the base times 9 sine 20. So it's 1/2, 2 radiuses, and the sine of the angle. So you can use trigonometry to do that. That's the proof in it. Or you can just remember 1/2 r sine of the angle. I think it's easier to do it that way. So now we're going to try and find the area of this sector. And we're going to try and subtract the area of the triangle just to find that piece right there. So if we're trying to find the area of the sector, x over the area of the circle equals arc measure over 360.
Oh, he was skipping.
So I can do the simplify step.
He was skipping.
I can reduce this fraction. 60 over 360 is 1 over 6. And then start cross multiplying. 1 times 16 pi is 16 pi. X times 6 is 6x. Divide both sides by 6. And I'm just going to type this in my calculator and get back a decimal answer. 16 pi over 6 is 8.4. So the area of the whole wedge is 8.4. Now I need to find the area of the triangle. Can you remember what that looked like? So it's 1/2 times the radius times the radius times the sine of the angle. What's our radius?
4.
What's our angle?
60.
So if we did 1/2 times the radius times sine of the angle, the area of the triangle is 6.9. So if I do 8.4 minus 6.9, it gives me the area of the dark piece. We're going to get 1.5. So the only reason I'm going to show you the last question is for this. The last question it might say, just for fun, find the area of the white piece. Find the area of the white
There's
piece.
2 white pieces.
The white piece.
I mean,
So now I want you to find the area of that. All the white piece.
So all as
So you
one.
have to do all that work and also find the area of the circle.
That's a lot of work. for
It's
one
not
question.
though. It's 2 different questions. And then instead of subtracting, you're gonna add. So, what is the area of this sector? Do we know how big that white sector is? X. What is the area of the circle? Has any of that changed? Now look. What is the degree measure that describes this arc? 140 describes the lower piece.
It's
You talking about like major home?
220,
220. How did you get that?
because 140 minus 360.
So 220 degrees over 360. Now I have an equation that's solving for this sector over here. So just that subtraction technique. X over 36 pi equals 220 over 360, which simplifies down into 11 over 18. Cross multiply. I think it's 396 pi equals 18x. Divide both sides by 18. $396 divided by 18 is 22 pies. So the area of that white sector is 22 pies. All I have left is to add the area of the triangle. So to this I need to add the area of the triangle, which is 1/2 times the radius times the radius times the angle of the triangle, or sine the angle of the triangle. 1/2 times 6 times 6 times sine of 140. 11.5. You need to add to that 22 pies, because that was the area of the sector. 80.6 or 80.7. That's the area of everything but the black piece. So your test will stop here. Your test will stop here. The area of the shaded region. I just don't want you guys to get confused when you see something like this. What are you going to use for your arc measure? 90
No.
or 270?
270.
Just be careful with that. Sometimes it's the dark shaded region. So we're looking at 6 questions. Nothing super crazy. We're going to do circles tomorrow. Circles on a coordinate plane. And unfortunately, I just found out 10 minutes ago I'm not going to be here.
What do you mean?
They moved all of our games up. So now JV plays at 4:30 instead of 5:30.
If we turn the crossword,
Is he-
would that be your schedule?
That's why I turned it
What did it do?
I know why.
I haven't done it yet.
Is it kind of weird?
I don't have it. I don't.
No, give it.